So this is 11.1. You need your tech and your desk. 11.1. This is the alpha lesson. And I have given up using the board to advance the slides. So I'm going to do it from over here. So here's what we're asking you to do. Hypothesis, null and alternate, expected counts. You've done expected counts before. That means the numbers that go in the two-way table. Chi-square test statistic. We're doing a goodness of fit today. We'll explain to you what that means. Conditions, degrees of freedom, the p-value. Well, the p-value is the same as it's been. Okay? And really what a chi-square test is this. You have z-test for proportions, t-test for means. You learn the z-test first. That's essentially a subset of chi-square tests. Chi-squares are tests of proportions. But what we can do, we can test two proportions at a time with a z-test. That's what you're being assessed on tomorrow. What's the difference of two proportions? Chi-squared would be 3 or more proportions, but you can do it in one test. So it starts with this. M&Ms are made in New Jersey. Who knew? You like M&Ms? Everyone likes M&Ms. So we should do this activity about the different color M&Ms. It's not a COVID-friendly activity, okay? So it's just disgusting. So did you know this? That M&Ms has this distribution of colors. There's double the orange and blue than the other colors. Why would they do that? Well, they publish this to create interest in their product. You're getting a free commercial because they're telling you what proportions are proportions correspond to each color, right? So we're going to take a sample of M&Ms and see if this is correct. I didn't get it. If there was a way to simultaneously get the sun out of Grace's eyes and send it to Fox's eyes, I would do it. But there's no way for me to do that. So here's what happened. They took this sample of 60 M&Ms and they counted out the colors. Make sense? It's where we're getting this number. These numbers, this table in the bottom. Then what? Well, we need to come up with a null and alternate. And you need to understand this. For the template, which you've seen already, but we're going to get at these FRQs in the spring. For the inference problem, you need to do this. Conditions, null and alternate, p-value, which corresponds to either the z-score, t-score, or chi-squared score. And are you going to reject or F2R? You need to do those 4 things for the inference question. But the question is not going to prompt you to do those 4 things. He's just going to say, is there a difference? Now, some people are writing that down. That's fine. But that's what is on the template. The template is in the Chapter 8 folder. It's in the Chapter 9 folder. That's what this is. That's the template prompts. The template that's filled out is in the Chapter 10 folder. So you have access to that. Okay? So here's what they're saying. You got to think about this because I found this up. I used to explain this wrong. And kids still achieve on the test. The null is that brown is 1/8, red's 1/8, yellow's 1/8, so on, till blue's 1/4. That's what they published. The alternate is not that these are not equal symbols. The alternate is one of them's wrong. But if one of them's wrong, two of them have to be wrong. Make sense? Because if one's wrong, those colors had to go somewhere else. So the alternate is at least two of them are incorrect. It's impossible to have just one be wrong. So there's your null and alternate. And that's where I was wrong. That all of them are wrong. That's the way I used to write it. But that was not correct. So where are we? Well, our sample size is 60, so we're going to multiply 60 times the advertised proportion. So we would expect to get these values. 15 orange, 15 blue, and half as many of the other colors. Where did we get that? The sample size times the proportion that was advertised. Is that logical? You don't have to sit that far back. You can move up here too.
No, it's
Okay. So now what? Well, we're not going to do this, but they built this table. We're concerned about this table right here. But they went over here to this bar graph. And blue is what you got out of the 60 M&Ms. And red is the expected. They don't match. Make sense? Not even one of them matches. Except what? There's millions of M&Ms. And we picked 60. So could the difference be attributed to random variation with sampling? Sampling variation. But that's why we have to quantify this. No one's interested in your opinion. I think, no one cares what you think. You need to quantify it. So all of these are off, but are they off by enough to consider that to be statistically significant? So here's how we're going to do this. We're going to do a chi-square test. Goodness of fit test. So you are going to go here. On your calculator, you're going to put the observed in list one. When I say list one, if you got something in list one that you want to keep, just move over one. But put observed in list one and put expected in list two. Now, this is kind of ironic because Fox is the only one who does not have the test on his calculator, and you can't get it on an 83. So my recommendation to Fox is this. Did he upgrade to an 84? I'm not telling you to buy an 84. You can borrow one from somebody who's a senior who doesn't have math. Or just switch them out, because there is no way to put this test on that operating system. And this question is not a big deal. We're going to show you right now how to do the problem on an 83. But it's kind of confusing when you weren't going to do it again until, oh, I got an update. The test is not May 13th. We got an email today from College Board. The only test they're moving is our test. They're moving it to Monday, the 7th. I don't know why. They could have been.
That's my birthday.
Okay. So the test got moved from Victoria Ryan's birthday and Jordan's birthday, the same as Victoria Ryan? You two switch, that's why you're to Mallory's birthday. This one is it's still a PM test. Like, for whatever reason, they're not offering any tests on the 13th. I'm not sure why. But I got that email today at lunch. Well, it's not really going to affect us. It's, a couple days. So we have our list loaded up. Ready? Here is the chi-square test statistic. It is. This is on your formula sheet. Meaning, when you go into the resources folder in Canvas, the formula sheet's there. When we went over the FRQ on Tuesday, this formula is in there. It is observed, take away expected, squared, that's why it's chi-squared, divided by expected. So what was the first one? The first one was brown. So there were 12 brown M&Ms, subtract 7.5, which was the expected number of brown M&Ms you would get out of 60, square it. Why? So the negatives don't work against the positives. Does that make sense? See, because this number's positive, that number's negative. But it doesn't help us to have the negatives work against the positive, because the test statistic would be low. When in reality, it wasn't low. So we square it, we divide by this. So you're going here on your calculator. Go to list 3. Yeah, listen, you're not in the first row. You're going to do this, Fox, because you're the one who has to do it by hand. List 3, top of the list, where L3 is highlighted. If you're in the first cell, you're going to get an error message. Top of the list, type this. Open parentheses. Second 1. Subtract. Second 2. Close parentheses. X squared key. Division key. Well, no. Delete the division key and just push enter. And it'll populate your list 3. You there? Now go to list 4 at the top. And type this. Second 3 divided by second 2. You understand what you just did? You did list 1, take away list 2. Squared it, then divided it by list 2. And we're going to do this all at once instead of adding these up at the end. So now it goes second quick, second stack, second stat math, 5 for sum, the sum of list 4, and you got what? Yeah, you better have gotten this, because 9.8, which is what? That's your chi-square statistic. But that doesn't mean anything to you until you compare it to the critical value. Okay? But the issue is, everyone in the room, except for one child, has this. Second quick. Stat, test, up arrow. And go to up arrow until you see chi-square GOF test. See it? You don't have it. Click on that. Now you understand it's prompting you? What's observed, what's expected. The degrees of freedom. There are 6 candy flavors. So there'd be 5 degrees of freedom. 1 less than the number of categories. Okay? Push calculate. You got the same answer. You got 9.8. Yes? Except you got more information. What else did you get? You got the p-value. Meaning using the test, it'll give you the p-value. We're going to compare the p-value to what? We're going to compare the p-value to McGarrigle's sweatshirt. Does that make sense? No. What we would compare the p-value to? Compare the p-value to the alpha level. We don't know what the alpha level is. What's the default? 0. What? Correct. 5%. Compare your p-value to 5%. What is it? 13%. Is it higher in the alpha level or lower? Thank you. 13% is higher than 5%. Do we reject or fail to reject? We fail to reject. You only reject the null if the p-value is small. Smaller than what? Smaller than the alpha level, which is generally 5%. What does that mean? It means if we back up here, even though these are all different, there is a lack of statistical evidence that the colors don't match the advertised proportions. Where are we here? The conditions. The conditions include this. SRS. Do we have an SRS of M&Ms? Yes. Do we have less than 10% of all the M&Ms in the world? Way less. We had 60 M&Ms. There's millions and millions of M&Ms. Now listen to the last one. This is new. Each expected count has to be at least 5. You understand what happened here? All the expected are at least 5. One of the observed is less than 5. Uh-oh. We don't care about that. And people are going to get confused about that. They're going to say, one count was less than 5. The condition doesn't apply to the observed, it applies to the expected. So all the expected values have to be bigger than 5. What is the null? The null is that the proportion of M&Ms are every color is 1/8 except 2 colors are 1/4. The alternate is at least 2 are different than that. The p-value is 13%. The chi-square test statistic is 9.8 with 5 degrees of freedom. The conclusion is we failed to reject the null. There was a lack of evidence that M&Ms are different than what they're advertised to be. Okay? And then that's for tomorrow. So, the hypotheses, it's a test of proportions. chi-square has nothing to do with means. It looks like, the hierarchy looks like this. We have chi-squared, and we have t-test. And a z-test is a subset of chi-square test. We just learn them in this order. This, that. A chi-square distribution is one-tailed. The picture's one-tailed, but the alternate is always not equal to. That's different for you. See, when you've done a one-tailed test up till now, you've had an inequality symbol in the alternate. Not for chi-squared. The alternate is always not equal to, even though it's a one-tailed test. You'll see what the picture looks like. This is the test statistic. The sum of observed, take away expected, squared, so the negatives don't work against the positives, divided by expected. Now, you're going to go to this problem set. 1, 5, and 3, meaning, right? 1 and 5 are a data set, they go together. Then come back to 3, which doesn't involve a data set. So we're going to pause the video for you to do those 3 questions. So for the M&M question, in order to get the chi-square test statistic, you would do this. Stat, edit, and we've got the observed in list 1, the expected in list 2. We would go to list 3 in the top and type this. Second 1, subtract second 2, we would square it. Now you could do this all in one step. You can then say divide that by second 2, because that was expected. And this is the algorithm that is on the PDF. Observed, take away expected squared, divided by expected. Then we go second quit, second stat, math, the sum of list 3. That is your test statistic. Except, we don't know if that's significant or not without doing the test. We would have to look up the critical value in the table for 5 degrees of freedom. So if you have an 84, you could just go here. Stat, test, and here's the goodness of fit test. So the newer operating system will have 2 chi-square tests. The older operating system will not. So the older operating system, you have to do what we just did in the list menu. If you have the newer operating system, you push enter. Observed was 1, expected was list 2. There were 5 degrees of freedom because there's 1 less than the number of categories. There were 6 colors of candy, less 1's 5 degrees of freedom. We'll calculate it. You can draw it, but we'll show you what a picture looks like on problems 1 and 5. You got the chi-square statistic that we just got, 9.8, but you also get the p-value, which you compare to the alpha level. So in this case, the p-value is greater than 5%. We would fail to reject the null. Then what? The contribution. It tells you how much of this 9.8 came from each of the colors. All right, so for problem 1, it's about types of nuts. And the null is, the cashews are 52%, almonds 27, macadamia 13, Brazil nuts 8%. The alternate is at least 2 of them are not that. Okay? So those are observed numbers in list 1. That was given to us. Here's how we get the expected numbers. We take the advertised proportion and multiply it by the sample size. So we have observed, take away expected. We need the expected, the lowest expected is 12. 12 is greater than 5, so we met the condition. The other conditions are, do we have less than 10% of all the nuts? So that's pretty clear. And then we have an SRS. So if we use the calculator to do the test, and instead of calculating, I push draw, you see the shape of the chi-square distribution. It's skewed. It's always skewed. Okay? The more degrees of freedom, the less skewed it is. But it's skewed. And it's always a one-tail test. So we get a p-value of 8% for the nuts. 8% is higher than 5%. Skip the 5. There were 4 types of nuts. There's 3 degrees of freedom. 8% is bigger than 5%. F2R. Fail to reject the null. See, we weren't close to this. We weren't close to the advertised proportion because the p-value is pretty low, but it's not low enough to reject the null. The probability that we got what we got by chance alone, if null been true, is 8.5%. But 8.5% is not statistically significant. There was a lack of evidence to reject the claim of the company. Then question 3 is different. So we back up to question 3. And it says, suppose your test statistic is 19.03. What does that mean? 19.03 is the sum of observed, take away expected, squared, divided by expected. So that number is not going to mean anything to you. It's just some number. It doesn't help us without the p-value. So they said, okay, let's compare this. Ready? If we had 11 degrees of freedom versus 3 degrees of freedom. The same test statistic. So you go here on your calculator. Go to second distribution. Chi-squared CDF. Careful. Don't type PDF. It's just going to give you the height for the input. You want the area. CDF. Now what? Well, we can go from 0 to 19.03, and that would be everything except what's shaded in. And that's what I did here. Now look at this. I went from 0 to 19.03, 11 degrees of freedom. That gives me 94%. One take away, that is 6%. You're going to do something different. You're going to type this. Second distribution, chi-squared CDF. You're going to begin at 19.03. Comma, you need a large number to the right. I don't know, 500. Comma, 11 degrees of freedom. It's going to take you right to the 6%. Yes? Now what? Well, this test statistic of 19.03 gives you a p-value of 6%. We would F2R at 5%, but we would reject at 10%, depending on what the alpha level is. Like, when I say 5%, that's the default. But you could get prompts to use other alpha levels. And this test statistic takes you to the body at an alpha level of 5%. It takes you to the tail with an alpha level of 10%. But now on your calculator, do second enter and type over the 11 degrees of freedom with 3 degrees of freedom. So if you had 3 degrees of freedom, you're absolutely in the tail, because your p-value is essentially 0, because the distribution looks like this. 3 degrees of freedom will look like that. "11 degrees of freedom would look like that. Because as you have more degrees of freedom, you're pushing down on the curve. So the same value out here is going to be capture less of the curve with more degrees of freedom. Okay? So that is it.